Okay guys, we're going to get into the area rule today. Alright, and the area rule is a special formula we can use to find the area of any non-right angled triangle. So we know that the area of a triangle is equal to half base times height, right? So that's the formula for the area of a triangle in general. But what if we don't know the height? What if we don't know the height of our triangle? Well, that could lead us to a little bit of difficulty if we needed a specific formula of half base times height. But what the area rule does is it actually gives us a little bit of help because we don't actually need the height of the triangle. So I'm going to try and do Inktoshape, and let's see if this works nicely for me because I want it to look a certain way. Yeah, that's perfect. So let's call this point down here A. Let's call this point B. And let's call this point C. Alright? And then I'm going to have an angle in between here. And I'm going to call that D. Okay? Now, what we need is we're going to try and find out the vertical component of a line there. Okay, so let's go across like that. Because I can know the base. The base is just going to be AB. But the height is what I don't know. So this is going to be the height of my triangle. And this here, this length AB, is the base. Okay, so now there's this issue that if I have this angle D, well, I don't want the sine of that side. I want this angle here because that's going to help me find my height. This angle is going to be 180 take D. So we can now say that to find H, the sine of 180 take D is equal to the height over BC, because BC is my hypotenuse. Well, do you remember from yesterday that the sine of 180 take A equals the sine of A? Remember that rule that we worked at the end of yesterday's notes? So I can say that this is actually equal to the sine of D is equal to height over BC. And in turn, BC times the sine of the angle D equals the height. Well, again, area of a triangle is equal to half base times height. And if this here is equal to the height, for any triangle, because that could be any line, so for any triangle, area is equal to a half times AB, which is my base for that triangle, times BC, which is this line, times the sine of the angle D. That is for that formula here is for this specific triangle, but we can now generalize it for any triangle, and we're going to do that below. So, for all triangles. Okay, and now let's just draw a rough triangle here. Okay. Actually, that looks a bit too equilateral for my liking, and I don't want it to look like that. So let's try again. That's a bit better. So let's say that's C. This is B, and that's A. And this is going to be the angle inside, but this is a capital C. We're going to probably use capitals with our angles. We'll probably talk about that a bit more with sine rule and cosine rule, which is the next lesson. But just remember that our angles are usually at the top. And so the area of any triangle is equal to A times B times the sine of the angle C over 2. A times B times sine C over 2, and that is the area of any triangle. And I'm just going to write it in words here. The area of a triangle is half the product of two sides multiplied by the angle in between them. So if you have a triangle and you have two sides and the angle in between them, you can find the area of that triangle using the sine rule, okay? Really quite straightforward. So find the area okay? So I want to find the area of the following triangles. Again, ink to shape, my new favorite invention. So let's go something like that, like that, like that. Cool. So let's say this is 8.5 centimeters. Let's say this is 12.4 centimeters. And in here, that's 35 degrees. Well, we just said the area rule. Area equals AB sine C over 2. A and B are two sides. Sine of C is the sine of the angle in between them. So now I just substitute all of my values into my equation. 8.5 times 12.4 times the sine of 35 over 2. And that is going to be equal to 30.23 centimeters squared. We are finding the area of our triangle, so you always still have to include area in your final answer. We need that unit squared at the end. If you don't have unit squared, guys, you will probably lose a mark. It's year 11 methods. You need to know that you need to put units in your measurement answers. Question B. Another cool triangle. Okay. So let's say that this angle in here is 105 degrees. And then we've got 7.2 meters. We've got 4.9 meters. Area equals AB sine C over 2. Two sides and the angle in between them. That gives us our area. Substitute my values in. 7.2 times 4.9 times the sine of 105 all over 2. Okay. Now I'm just going to do it in my calculator because I want to try and point something out. Okay, so if I'm going to go to main, make sure you're in degrees in that settings. I'll do that again make sure you are in degrees when you're working with that setting, because right now we're working with degrees, otherwise your answer is going to be off. So we've got 7.2 times 4.9 times by the sine of 105. Well, that's going to be equal to 34. Then I'm going to divide that by 2. 17.038, and I can probably round that up to 17.04 centimeters squared. Oh, sorry, meters squared. Meters squared. All right. Another example. If the area is 7 centimeters squared, find x. Okay, so we want to know the value of x if the area of the triangle is 7 centimeters squared. Okay. Well, let's just figure out our formula first. So our formula is that A equals AB sine C over 2. Well, let's plug in all of our values now. Okay, so the area is 7. And 7 is equal to, well, 4 times 5. So let's just say 20. 4 times 5 is 20, so I'm just going to leave that as 20. Sine C over 2. Well, if I times this by 2, that's going to get me to 14, and then dividing by 20, 14 over 20, or 7 over 10. So that's going to get me to 7 over 10 is equal to the sine of C. And then to find the value of C, I need to use my inverse function. So sine -1 of 7 over 10 is equal to C. And that's going to give me 44.4. So therefore, x is equal to 44.4 degrees. Now, our calculator actually has a really cool feature that we can use for so many of these trick problems, and I'm going to talk about that right now. So you're going to go to menu, and then you're going to go to the geometry section, okay? Honestly, the geometry section is one of my favorite ones because it does so many cool things with triangles and trig, and it's basically like cheating. So we've got our options at the top here. You want to go into this one here, and this is how you can select your shape. I'm just going to pick that one, and then you just draw a bit of a space, and then your triangle is going to appear for you. Okay? So to match the triangle that I've drawn, I can select a side here. Oh, sorry, it's gone. I can select one of my sides here. So I'm going to select this side right there. Once I've selected this side, I've pressed this arrow at the top right. And so it's saying right now this is 12.094555 units long. Well, I want it to be 5, matching my diagram from my notes. So I want that to be 5. I press enter, and now it's locked in. So that is now saying that this length is 5. Well, now I want this here. So saying right now this is about 4.69. Well, I want to change that, and I want to say that that is equal. So I press there, say that's equal to 4. I lock it, and then I press enter. So now if I go to this side here, that should be 5. And if I go to this side here, that should be 4. Alright? Now, if I select all 3 sides, so this side, that side, you see it's got a trapezium, but it's shaded in. That is telling you the area of this shape. So by selecting all three sides of my triangle, that is telling you the area of this shape up here. But we want the area to be 7. So let's change that to 7, lock it in, 7, enter. Oh, it's because I have to change the angles first. Okay. Strike that. I want to change something else first. If I select 2 sides, it tells me the size of my angle in between, okay? So by selecting these 2 sides, it tells me this angle BCA there, okay? So let's say now I change that, and I change it to what our answer was, 44.4, okay? Locked in. Well, now that's saying that's 44.4, and now I've got this side is 4, that's 5, 44.4. If I select all 3 sides now, I should be getting to about 7 centimeters squared, and it's 6.9999. Probably because I've rounded my answer for C to 44.4. But you can see what we've got here now, okay? It's really a great tool in terms of how we're doing this. Once you get to complex sine and cosine rule problems, we can also use this tool to try and help us out in that situation, okay? So hopefully that has helped you all with all of these problems. Go do chapter 1B from Sadler, and hopefully you will be able to do these problems now.